Welcome everybody, this is section 6.4, solving equations with rational expressions. So our objectives today: determine the domain of the variable in a rational equation, and then solve rational equations. So rational equations are equations that contain rational expressions, such as these. So for the warm-up today, find the domain of those two rational expressions. So just a reminder, at this point you should pause the video because I'm just going to go right on. I'm not going to pause. So to find the domain, we want to avoid division by zero because anything involving division by zero is undefined. So we're going to set these denominators equal to 0. So 4x minus 12 equals 0. And x squared minus 3x minus 10 equals 0. So this one, we get x equals 3. And so the domain of this is every real number except x equals 3. Because for all the other real numbers, we can plug them in, we don't get 0 in the denominator. But if I plug in 3 here, I'm going to get 0. So we're going to write this using separator notation. And so x such that x does not equal 3. So this means all real numbers except x equals 3. So here we're going to need to do some factoring. So this factors into x minus 5 times x plus 2 equals 0. And then solving these individually, using the zero factor property, we get x equals 5 and x equals negative 2. Now we're going to determine the domain of rational equations. And so what we need to do here is find the domain of each of these rational expressions individually, and then find the intersection. So for this one, if I plug in 4 here, and you don't need to go through and actually solve little equations like this. I assume you know how to do that by now. So for this, if I plug in a 4 here, I'm going to get division by 0. If I plug in negative 1 here, I'll get division by 0 here. And if I plug in a 2 here, I'll get division by 0 here. So that's the values excluded from the domain for all three of those individually. Now we'll just combine them all in one statement. So I'll say x cannot equal negative 1, 2, and 4. Your turn, number 1. All right, so for this one, if I plug in negative 3 here, I'll get division by 0, so can't have negative 3. Plug in 1 here, or 7 here. So those are the three values that cannot be in the domain. So the domain is all real numbers except negative 3, 1, and 7. For the next example, some factoring is going to be required, so make sure you do show the factoring. So we got division, we have a difference of squares here, so that factors into x plus 3, x minus 3. And this one, factors into x minus 3, x plus 2. So now we can just find all the values that are going to produce 0. So I can plug in negative 3 here, and that will produce 0. Negative 2, and then these match, so I'll just do 3. So the domain is all real numbers except x equals negative 3, negative 2, and 3. Your turn, number 2. So this quadratic is going to factor into x minus 4, x minus 5. And here we have another difference of squares, x minus 4, x plus 4. Keep in mind that the numerator is totally irrelevant to finding the domain. Just ignore it. We're only concerned with the denominators because we only exclude division by 0. Alright, so to avoid division by 0, we could plug in negative 4 here and get 0, so we've got to avoid that one. Then 4, that one matches, and then 5. So all real numbers except negative 4, 4, and 5. So this is going to be the first step in solving rational equations. We have to determine the domain of the variable. And then we're going to clear the fractions. We're going to get rid of all these fractions by multiplying by the least common denominator. All right, then we'll solve the resulting equation. And then once we have a solution set, we have to compare that solution set with the numbers that are excluded from the domain. And then anything that matches, we're going to remove that from the solution set. First example. So first thing we're going to do is we're going to find the domain. So the only number that can produce division by 0 is if I plug in 0. So the domain is all round numbers except x cannot equal 0. Now we need to find the least common denominator. So 20 is a multiple of 4, and we have got an x here. Largest exponent is 1, so that gives us an LCD of 20x. So we're going to multiply this entire equation by 20x. Make sure you put parentheses around the equation to indicate that we're going to distribute into it. Alright, first fraction. The 20's cancel, so what we're doing here is multiplying x by negative 3. So negative 3x. Next up here, the x's cancel, so we're multiplying 2 by 20, so plus 40. Equals 20x divided by 4x is 5. 5 times 5, 25. Solving this. Gives us x equals 5. Now we compare this with the numbers that are excluded from the domain. No matches. So there's a solution. Your turn, number 3. So just like the example, we can't have 0 plugged in for x. LCD. See, 4 is a multiple of 2, got a single x, so 4x is the LCD. So we're going to multiply this entire equation by 4x. So here, the 4x's cancel, gives us a 3. Here, 4x divided by 2x is 2, 2 times 5 is 10. Here, the 4's cancel, leaving just x, so minus 7x. Solving, we get x equals 1. 1 is not one of the numbers excluded from the domain, so that is our solution. Now keep in mind, whenever you solve an equation like this, you should always take whatever you get, plug it back in, just use your calculator to figure out if it is indeed a solution. Great way to find mistakes. Next up, factoring will often be required. So factoring different squares here, we're going to get x plus 4, x minus 4. Alright, so let's see what we're going to exclude now. If I plug in a negative 4 here, I'll get division by 0, so x cannot equal negative 4. And here, positive 4. And then those match, so that's it. Now the LCD, we have two unique binomials, x plus 4, x minus 4. Greatest power is 1. So we'll multiply this whole thing by x plus 4, x minus 4. Alright, this fraction, the x plus 4's cancel, leaving just 1 times x minus 4. Here, the x minus 4's cancel, so we're going to multiply x times x plus 4. Remember to put that in parentheses, so we need to distribute. And over here, both of them cancel, so that equals just negative 8. Now distribute and simplify. So that gives us x squared plus 5x minus 4 equals negative 8. Now I'm going to bring everything over to the left-hand side, so I'm going to add 8 to both sides. Gives us x squared plus 5x plus 4 equals 0. Now we need a factor here. So that factors into x plus 4 times x plus 1 equals 0. Now we use the zero factor property, setting each of these individually to 0. So x plus 4 equals 0 as a solution of x equals negative 4, and x plus 1 equals 0 as a solution of negative 1. So negative 4 and negative 1 are our solutions, except notice that negative 4 is one of those values that's excluded from the domain. So that cannot be one of the solutions. So x plus 4 is gone, and the only solution is x equals negative 1. Your turn, number 4. First thing we're going to do is factor this denominator here. We may need to factor the numerator in some situations, but in this case it ends up being not necessary. So x squared minus 5x plus 4 factors into x minus 4, x minus 1. Now domain, 1 will produce division by 0, so x cannot be 1, and 4 will produce division by 0. So all our numbers except 1 and 4. Now the LCD, we have two unique binomials. First power is the highest power, so we'll multiply the entire equation by x minus 4, x minus 1. All right, over here, first fraction, x minus 4's cancel, leaving 5 times x minus 1. Here, x plus 1's cancel, leaving behind negative 3 times x minus 4. And here, both of these are going to cancel, so we just get the numerator, x squared minus 1. Now we're going to distribute. Simplify. I got a mistake here. 3, yes, here at 12. I knew there was something wrong. Okay, so that is 7. That's better. All right, now I'm going to get everything over here to the right. So we got x squared minus 2x minus 8. Now that's factorable. Into x minus 4, x plus 2. And solving that using the zero factor property, we're going to get x equals negative 2 and 4. So comparing that with the numbers excluded, 4 is excluded, so that is not a solution. So the only solution is x equals negative 2. Now, not every rational equation has a solution. So now we're going to look at an example with no solution. So we'll start by factoring this into x times x minus 4. All right, let's look at these denominators. It's like 0 is excluded. And if I plug in 4 here or here, we get division by 0. So 0 and 4 are excluded from the domain. All right, so we've got x times x minus 4. There's our two unique factors. So we're going to multiply this entire equation by x times x minus 4. Here, the x minus 4's cancel, leaving just 6 times x. Here, the x's cancel, leaving 5 times x minus 4. And here everything cancels, so we just have equals -2. All right, now distribute and simplify. Oh, I forgot my 0. There we go. Okay, now I'm going to add 20 to both sides and then combine these. So we get 11x equals 0. Dividing by 11, x equals 0. But 0 is excluded from the domain, so this is not a solution. So the solution is the empty set. No solution. Your turn, number 5. So we'll start by factoring here. We have difference of squares. That factors into x plus 1, x minus 1. So that means the domain will be all real numbers except -1 and +1. Now the LCD, we've got two unique binomials, x plus 1, x minus 1. Now I'll distribute this in. So here, the x plus 1's cancel, so we're left with 3 times x minus 1. Here, the x minus 1's cancel, so we're left with 1 times x plus 1. And here, everything cancels, so we just have -2. So you're at 3x minus 3 equals x minus 1. Your 2x equals 2. Or x equals 1. But 1's excluded, so there is no solution. Next example is a particularly nice form of a rational equation. All right, so here you have a -6, that's going to produce division by 0. Set 2x minus 1 equal to 0, we get 1/2. So those two values are excluded from the domain. Now, just like any other equation where we've got two fractions set equal to each other, we can just cross multiply. All right, so I'm going to do x plus 6 times 2x plus 3. Equals x minus 4 times 2x minus 1. Now, FOIL. we got minus x, minus 8x, and plus 4. All right, first thing, we've got a 2x squared on each side. We can subtract that from both sides, so those go away. Now we'll combine like terms. And we get 24x equals negative 14, solving for x. We get x equals negative 14/24, which reduces to negative 7/12. That's not one of the excluded values, so there's our solution, negative 7/12. Your turn, number 6. All right, so two values that produce division by 0 are negative 3 and negative 2. Now we'll cross multiply. All right, now we can FOIL. Now, it's not always the case that you're going to matching x squared terms and be able to cancel them like that. If you don't, generally what's going to happen is you're going to get a factorable trinomial, and you can use the zero factor property to solve that. All right, 5x squared, so those go away. So we get x equals 7/3. It's not excluded, so there's our solution, 7/3. So we're often going to get fractions as results, so make sure you can handle that situation. All right, the domain. So when you get 0 there, and here, you get negative 1/3. If I plug it in, negative 1/3 here, I'll get 0. So x cannot equal negative 1/3 and 0. So you have two unique factors. We have x and 3x plus 1. So we'll multiply this by x times 3x plus 1. For this fraction, the 3x plus 1's cancel, and you just have 2 times x. Here the x's cancel, so I have 1 times 3x plus 1. Here the 3x plus 1's cancel, So we have negative 6x times x, so negative 6x squared. All right, now I'm going to get everything over to this side. So subtracting 3x, we get minus x there, minus 1 equals 0. All right, so I'm not going to go through all the steps, factoring by grouping to get that, but make sure you do, if you do on your homework or on exams, show all the steps there. Unless that's one you can just figure out. And this one, since we have a prime number here, it's not too tough to figure that one out. Okay, 2x minus 1 equals 0. We're going to use the zero factor property here. And 3x plus 1 equals 0. So this one, we get 1/2. And this one, we get negative 1/3. All right, so there's our two solutions, but negative 1/3 is excluded. So this one's out, and x equals 1/2 is the only solution. All right, pause the video and go ahead and work on your turn number 7. All right, 0 and 2 are excluded. Now we're going to multiply this by the two unique factors x minus 2. Okay, so distributing in, the x minus 2's cancel, leaving 2x times x. That is 2x squared. Equals. X's cancel. So we got negative 3 times x minus 2. And here, x minus 2's cancel, so we have plus 4x. Distributing, negative 3x plus 6 plus 4x. So we got x plus 6. Now move everything to the left. So we get 2x squared minus x minus 6 equals 0. All right, so that factors into 2x plus 3 times x minus 2, setting each of these individually equal to 0. We get x equals negative 3/2 and x equals 2. 2 is excluded, so we get rid of that one. Only solution is x equals negative 3/2. Now some of these require quite a bit of factoring. So this factors into x plus 2, x plus 1. Got difference of squares here. So that's x plus 2, x minus 2. And this one factors into x minus 2, x plus 1. So domain got negative 2 here, negative 1, and positive 2. All right, so now we're going to multiply it by all the unique factors. We got 3 of them now. Fortunately, we're going to have 2 cancellations on each fraction. So x plus 1, x plus 2, these all cancel. So what do we have? We got 5 times x minus 2. Here, x minus 2, x plus 2, those all cancel. So what do we have? We got negative 3 times x plus 1. And over here, we got x minus 2, x plus 1. Those 2 are going to cancel. So that leaves us 1 times x plus 2. All right, now distribute and simplify. So 2x minus 13 equals x plus 2. Subtract an x, add 13, and we get x equals 15. 15 is not excluded, so there's our solution. All right, last one, your turn, number 8. All right, we're going to factor these. So this one factors into x plus 3, x minus 2. Difference of squares, x plus 2, x minus 2. And we got x plus 2, x plus 3. All right, our domain. Need a little bit more room here. All right, negative 3, negative 2, positive 2. All right, now we're going to multiply this by all the unique factors. So we have x minus 2. What am I doing? Okay, x minus 2, x plus 2, x plus 3. Now distributing in. All right, we're going to cancel x plus 3 and x minus 2, leaving x plus 2 times 4. Here, x minus 2, x plus 2, those both cancel. We got negative 1 times x plus 3. So just negative x plus 3. I'm going to put in parentheses. You're going to distribute the negative into that binomial. All right, over here, x plus 2, x plus 3, those both cancel. So we got 2 times x minus 2. Distributing. All right, simplify. And we get x equals negative 9. It's not in the list, so that's a valid solution. So that is it. And that is it for today.